Good afternoon, everyone. I think we're getting quite near the end of the day. First of all, I just need to say a couple of words about Senetas, because it may be surprising to find us presenting at a SafeNet Gemalto event, but Senetas are an Australian engineering company, and we specifically do layer 2 encryption. That's all we do. One product company that we've been doing these kind of technologies since 1997. For many years we had a license agreement with SafeNet where they manufactured the product and a license in the US. Slightly different to the Australian model that we made, but very, very similar. But in 2013 we actually had a change in that relationship. So the way things work now is that if you want to buy a Senetas product anywhere apart from Australia, then you buy it through the SafeNet Gemalto channel. So they are our global distributor for the product. Senetas is really a very strongly engineering-based company. So there's no more than 50 people in Senetas. 16 of them are employed in the development of the product. A high proportion of others are technical people as well. So you can see the list there of things that we actually create for this product, and the kind of engineers that we have in our offices. Being a small company does mean that we are pretty flexible, so it's meant that over the months and years we've been able to quickly develop options and solutions that customers request. So recently we were able to introduce transmission security capability within a few months. We've been able to nest layer 2 encryptors, so we've been able to do spoofing of different protocols, all sorts of things that we can introduce quite quickly just because we're a very small and agile company. So those are just the two compulsory slides that you have to have about the company. The rest of it, I'm really going to talk about fibre tapping. I'm not going to talk about the product per se, because 20 minutes really isn't long enough to go through all the capabilities and the good things or otherwise of layer 2 encryption. But what I thought, given that it's getting near the end of the day and people start to get a bit jaundiced, a bit jaded at this stage of the day, I thought we'd have a bit of audience participation. Okay? So don't worry, don't look scared, nothing embarrassing, nothing horrible. Just a bit of imagination and hopefully help you visualise why we encrypt layer 2 data and what the risks are of having data in transit. So I want you to imagine that this is the company head office, and at the back there is the company disaster recovery centre. So would you mind being the disaster recovery centre? If you could look like a big awkward building at the back, that would be great. Now you guys in the middle, you are the public, you are the street, the buildings, everything that is between me and my data centre. And I'm going to send some data across the link, and in this case it's going to be my debit card. So what I would like, I'm going to approach this gentleman here. I would like you, sir, to convey my debit card to the back of the room to my disaster recovery centre. So if I give you that, can you send it on its way by whatever means you think is appropriate? It's not going anywhere. Do you understand? Oh, he's a good man. Yeah. Excellent. Thank you very much. So if you can hand it to anyone at the back there and come back, that would be great. Sorry. So well, that's quite a good illustration, actually, because one of the possibilities, once I release control of that data, once it steps outside of my office, I really don't know what's going to happen to it. I've put my trust in someone else to deliver the data to the far end. I don't know whether he's going to look at it. I don't know whether he's going to misdirect it. I don't know if he's going to pass it on to half a dozen other locations between me and the destination. And that is the essence of why we encrypt layer 2 data. As soon as I release it from my office, I've lost control. I don't know what's going to happen to it, and I can't guarantee that no one has seen it that shouldn't have, and I can't guarantee that I'm going to get it back. So what I'd like to do now is just show you one of the ways that the data could be captured or interfered with on the route to a data center or to another location, to a cloud service, whatever it might be. We've got one method showing in the exhibition room just outside. So that's a micro bend fibre tap. So the way that works is we put a little bend in the fibre, light escapes from the fibre and is captured in a prism at the base of an optic clamp. Enough light escapes from that method so that we can reconstruct the data. And you should have seen that, or you've had the chance to see that throughout the day. It's not been working as well as it always does, but it does kind of work. The method I've got at the front here, which hopefully the guys will be able to show on the camera, is called evanescent tapping. And this is a slightly more sophisticated way of tapping a device, and it's very hard to detect this kind of method. What evanescent tapping is polishing an existing fibre. So you just get a little jig, you lay the glass in the jig, and you polish across the top, and maybe you polish 5%, 10% of the fibre away. And you get another fibre, and you polish it exactly the same amount, and then you fold the two together, and optically, they are one fibre. So light is just going to stream along that, and it's going to pop out of either of the fibres. So what I've got here, can we get the video on the? Okay, yeah. So what I've got here is a source over here, a destination over here, and a fibre tap in here. So what I can show you is, because I'm bleeding off some of the light from the optic coupler here, if I switch to my Wireshark, just continue without saving. Switch back to the HDMI, there we go. So you can see on there, I'm streaming a video file, so you can see all the UDP packets going across that link. I can see the IP address of the source device. I can see the multicast address that I'm using for that data. I can see, certainly I can see other things as they go through. And just to prove I'm not cheating, if I unplug there, you can see the video now has stopped being received. So I can plug it back in, and back we come. So easy, very easy to detect or to tap into video sources. Historically, we've had a lot of trouble with sort of unbelief. People never really believed that tapping fibre was possible. And I still think that people think it's difficult. But hopefully the two demos that we have show that it's pretty easy and not expensive to do either. We can imagine that if someone's got a much more sophisticated approach, mentioning no names, but Mr. Snowden has told us a great deal about those names, we can imagine how easy they would find it to tap multiple fibres and multiple rates as well. So I guess the contention is, can you protect yourself without needing to encrypt? Because obviously encryption is, in this kind of high-speed environment, is quite an expensive process, and people would like to avoid having to use the encryption if they possibly can. So we get quite a lot of pushback from customers when we talk about this risk. One of the things we get is people will talk about optical time division and reflectometry. What that mouthful means is that if they detect a difference in the light level, if the light changes because we've stolen some of it, then they will detect that. And that's perfectly valid. Yes, they will detect it. If it's beyond a certain level, maybe a dB or something like that, they'll detect it. They'll also say, well, it's okay, we've got other precautions, we've got CCTV, we've got inert gas chambers, so if anyone opens the cabinet, then we're going to detect them and we're going to rush out and arrest them or whatever. We have had customers also who encase their fibre, and I mean really encase it, sort of wrap it all in bituminous tape, seal it in concrete, make it as inaccessible as possible. And we have people who say, well, it's okay, we've got dark fibre, by which they mean we've got a long length of fibre that doesn't have any interruptions anywhere between the beginning and the end. In my experience, not often actually the case. People think they have, but they haven't. So I guess the risk comes down to understanding who is your attacker. So if I'm the fibre tap or the data thief, who am I? I mean, am I just some amateur who read about how to tap optical fibres on the internet? Am I a serious criminal? Am I a state government? Am I a cyber criminal? Depends who I am, what my capabilities are. What do I know? Am I just opening up random pits in the street and hoping to strike gold? Do I know where the data runs from the bank at the end of the street? It's interesting to note that most providers helpfully label their fibre cables in the pits for diagnostic purposes. So if you open it up, you'll find that it says who the fibre belongs to. Do I know the wavelengths? Again, that's an important thing for me to know. But even if I don't know, I can surely find out. I can buy another little device for 1,500 euros, and I can check what the wavelength is on a particular fibre. So all in all, if I'm serious, I can find out quite a lot, and I can find out how to access your links. What's it worth? So we don't pretend that everybody needs layer 2 encryption, because clearly people may be sending data that's really not that sensitive or not that important. But if they are sending data, one thing we can be reasonably sure about is that it's current information. So if you're doing a download at the end of the business day, you'll be sending information that relates to that day's transactions, that day's business. And if it's financial information, if it's intellectual property, I'm sure you can think of loads of other possible types of information that you would not want to be falling into the public domain. Certainly intellectual property is, I think, a big one. If IP is your lifeblood, the moment somebody else has got that information, your company is done. So you must protect that kind of information. Window of opportunity. One of the surprising things, perhaps, is that when people install fibre optic cables, quite helpfully, they may put a Y splice, just something similar to what I've done here. They may put in a splice for diagnostic purposes. Very helpful for you as an engineer, but also very helpful for me if I happen to know that you've done that. If someone is trying to use the light level changes to detect their someone's attempted fibre tap, well, that kind of assumes that the fibre tap hasn't always been there. If it was installed with the link, you're never going to see a difference. So there's plenty of ways in which you can imagine fibre optics can be tapped without it being discoverable. And we have got documented instances, as you know, of such events occurring. So all in all, we assume that I have the necessary skills, that I know what I'm doing, that once I get in, I'm not going to be challenged, I'm not going to be discovered. One of the practical demonstrations of this that we've done in multiple countries now is we've had people dress up, high visibility jackets, hard hat, get a bit of fencing, go and open up a pit and just sort of go down the pit with a laptop. We've done this in Switzerland, in Australia, I think in Germany as well. Nobody ever challenges a man in high vis with a hard hat. So that you can just go in and you can do whatever it is you want to do. No one's gonna challenge you on it. They may even come and help. I suppose the other thing is, what do you do if you think you're being attacked? What do you do if you see a light loss on your link, if you see a brief interruption? It's a tough one to call, isn't it? Because it's probably a critical link. Certainly it's a high speed, maybe it's a high speed link between your data center and your disaster recovery site. Are you going to take down the link just because you saw an 11-second interruption? 11 seconds is how long it takes you to re-splice a fibre with a proper fibre splicing kit. So you've got some choices, what you're going to do. Are you going to send out an engineer? Are you going to switch over your links? It's a difficult one because you don't know what I knew and you don't know what I'm up to. So yeah, well, false alarm methods, I won't go into these because I see my time is getting near to an end. So our main message is this. If your data is worth millions, it's worth spending thousands to encrypt it. We don't pretend that there are sort of 12-year-olds down pits in streets trying to tap optical fibres. That's not the message here. The message is that if you've got got data that is of value to you and will be of value to other people, then you need to protect it in accordance with the value of the data. So this kind of attack isn't everyday stuff, but as you've seen here, there are relatively simple techniques that are on the internet. So you can go in and you can type in fibre tapping methods and you'll come up with at least 3 or 4 patented methods for tapping optical fibres. The information is out there. The design for the jigs to do the evanescent tapping that I'm showing here, that jig design is out there, just dimensions and everything. So people can do it if they've got the motivation. Okay, I'll stop there. I've got 1 or 2 more things to say if there's... Look at that. That's my 20-minute alarm. How about that? Okay, any questions? Okay. Thank you.